Here is an example, as you can see right here, guys. An automobile manufacturer advertises that its a new hybrid car has a mean mileage of 50 miles per gallon. Well, that's an advertisement. It could be a true advertisement or false advertisement. In order to check this out, you need to collect a sample of data and decide from the sample whether you have enough evidence to support the advertisement or you don't have enough evidence to support the advertisement. So there will be two hypotheses here, guys. The first one is called the null hypothesis. We assume that the advertisement is true, that the mean mileage is 50 miles per gallon. The alternative hypothesis that you learned how to work with on Monday will be that the mileage is not 50 miles per gallon. And we'll see which hypothesis will prevail. That's what you're going to learn today. In general, we don't know the true value of a population parameter. We don't know what the population means, guys, but we make assumptions about them. Either we can support our assumption or we cannot support our assumption. I mean, for the new hybrid car has a mean mileage of 50 miles per gallon. In order to check the entire population that this is true, you would have to check every single hybrid car, so this is just an assumption by the manufacturer. Okay. So we talked about two hypotheses on Monday, guys. The first one is called the null hypothesis. So you just put the null here, and the other one is called the alternative hypothesis. That's the null hypothesis, and the other one is called alternative. Okay, the null hypothesis is a statement of equality that contains one of the three inequalities as we discussed on Monday. It has to be one of the three. So the less than or equal sign, they say statement of equality. Why? This is less than or equal. It has an equal. Equal, greater than, unequal. It is denoted by HO. We read it H sub 0 or H naught. The null hypothesis often represents the status quo. That's what the previous belief, that what we believe to be is true, and we're trying probably to see whether it's still true or not true anymore. Previous belief. The null hypothesis contains the signs, so let me just put it again. This, that, or that one. All right. Alternative hypothesis. It's a statement of inequality. It has greater than, not equal to, or less than. The statement must be true if HO is false. As we discussed last time, guys, if one statement is wrong, that means the second one is true. So if HO is false, the null hypothesis is false, then HA must be true. It is denoted by HA and it's read sub A. The hypothesis is assumed to be true when the null hypothesis is false. Both the null and the alternative hypothesis should be stated before any statistical test of significance conducted. In other words, you technically are not supposed to do a data analysis before you state your hypothesis. First of all, you have to state your question. Anytime, guys, you collect data, you have to know why you're collecting data. So if you're testing a claim, you have to put the claim, the words, of the claim first, and then you go and collect the data to study the claim. So the alternative hypothesis contains the following signs. And remember, guys, when the null hypothesis has less than or equal to, the alternative will have a greater than. When the null hypothesis has equal, the alternative will have not equal. When this is a greater than or equal, then this one will be less than. The major purpose of hypothesis testing is to choose between two competing hypotheses about the value of a population parameter. For example, one hypothesis might claim that the wages of men and women are equal. The other one will be the wages of men or women are not equal. Or men make more money than women, or women make more money than men. So they have to be competing against each other. All right. The hypothesis actually to be tested whether it is still true or not true anymore is usually given the simple HO, which is the null hypothesis. The null hypothesis is assumed to be true unless there is strong evidence to the contrary. So this is how we're going to perform hypothesis testing, guys. We assume that our previous belief, the status quo, is still true. And then if we collect enough evidence otherwise, then we say it's not true. Just like the defendant in the court case. Whether we believe that the defendant is guilty or not, we cannot just start with our own belief. The court has to make an assumption that the defendant is not guilty. Otherwise, if they make an assumption the defendant is guilty, why the person has to go through trial? If already we think that the person is guilty, we assume no guilt, and we'll try, just to provide evidence against that. As I said last time, is if the prosecutor can provide enough evidence against the null hypothesis, which is that the defendant is not guilty, then the defendant will be convicted. We will reject HO and support HA if the data provide enough evidence against HO. Now, the evidence is measured by a test statistic, which we will talk about in a little bit. Okay, so let's go to the next page. Oops, I have a page 4 here. Let me just put the right page. 3. And 2, right here. Okay, I'll talk about those points later. How do we write HO and HA? We said, let's say it's about the mean. We're testing the mean. So you just put the mean and the mean right there. If this was equal, as we learned, let me just put a number here, 20. You learned on Monday that one should be not equal to 20. If this one was greater than or equal to 20, can a student tell me what should be HA in here? Yes. You can put the answer in chat. Less than sign. I hope that you guys are listening to me. All right, and as I said, guys, this is extremely important. That chapter is going to decide your scores on the remaining tests. And if you don't believe it now, you will believe that later. So that's very, very important that you pay attention to this. Participate with me. Try to understand this chapter well. And if this one is less than or equal to 20, guys, then that will be greater than 20. All right. Some practice. We're going to do some more practice. As I promised you, I told you we'll do more on Wednesday. Express the following statement using algebraic expressions, equation, or inequality. Use mu for mean, sigma for standard deviation, and p for proportion. And then write another statement that's opposite to the original. So the mean ID score is less than 120, guys. So that would be like this. That's the interpretation. And he wants us to write now a statement that is opposite to it. So let me just put opposite here. And you guys agree with me, it should be greater than or equal to 20. So remember, this one and that one together. That one and greater than are together, and these two are together. Any combination you have to have either these two or the middle two or the last one. A transportation company claims that the mean waiting time for a pickup is less than 15. It's the same thing, guys, as the previous one. And the opposite will be I'm not putting HO and HA yet. He didn't ask me for it. It's going to be in the next question. The standard deviation of test scores is no more than 4.5. Would the students please tell me what's no more means? What would be no more, guys, then? Which sign?
Is it less than or equal to 4.5?
Yes, that is correct. That is correct. Less than or equal to 4.5.
Where's the 20 coming from?
Oh, 120, I'm sorry.
Oh, okay.
You're right, 120. Thank you. So less than or equal to 4.5. And guys, the opposite will be this. Try to memorize those combinations, guys. You won't have any other combination. These are the only combinations. So that's the opposite. Okay, next one. A school administrator claims that the proportion, so you use P now, he talks about proportion, percent of students who score 300, 1300 or more in the test is 55. Is means equal sign, guys. And I think the opposite should be easy for you. It's not equal. Three more. You see, I'm putting in lots of examples on how to state the null and the alternative later. So because that's a very, very important step. Because if you state your claim wrong, you will be doing all the work based on a wrong claim. So you need to understand how to state the null and the alternative hypothesis. The mean cost of a new computer is more than $1,200. So mean, that's the sign. And then the opposite, guys, will be mean less than or equal to 1,200. The engineer hypothesized that the mean Brinell hardness of all such ductile iron piece is greater than 170 mean. So just use the word mean. And opposite, same thing as the above. Okay, let's see the next one. A manufacturer claims that the thickness of the spearmint gum it produces is 7.5/100th of an inch. So it's a mean, again, it's a number. Unless if he says percent or proportion, you use mean always. Most of the time, it's the mean. So is 7.5. And then the alternative, the opposite, guys, will be mean not equal to 7.5. I hope you understand the purpose why I'm having you write a statement and write its opposite, because later that's how we're going to do the null and the alternative hypothesis. Okay, so that's 2. And let's go to page 3 now. I have a few more. Proportion of flights that are delayed does not exceed 15%. So who can tell me what does not exceed means? You can't exceed 15%. So that means you cannot go over 15%.
Less than or equal to?
Yes, correct. I agree. And the opposite, guys, you know already the combination of signs greater than 15%. We claim that the mean nightly hotel price for hotel in South Carolina is no more than 65. And no more, guys, means less than or equal to $65. And then the opposite will be mean greater than 65. Okay. So as a summary, guys, let me write those signs again, how to interpret them. Less than is this sign. more than is this, does not exceed. I'm just gonna write this, that's in U. No more than so that's less than or equal to, at least greater than or equal to, at most less than or equal to, different, not equal. And you know, equal is equal sign. Okay, now, this is what we did last class, guys. This is where I spent almost 40 minutes just stating those hypotheses. We're gonna do some more. Write the claim as a mathematical sentence, state the null and the alternative hypothesis, and identify which one represent the claim. A school publicizes that the proportion of its students who are involved in at least one curricular activities is 61%. So is means equal. So the equal we know has to be in the null hypothesis. Remember, HO only can take one of those. And HA only can take one of those. And these have to come together always. So P is 61%. And guys, agree with me that P not equal 61% should be in the alternative. And the claim happened to be in HO. Sometimes the claim is in HO, other times the claim in HA. But in real life, guys, we try to not to support HO. So most claims should be in HA. If you want to speak in favor of your claim, it has to be in HA. But it doesn't mean that it's gonna fall in HA. Here he says equal, so the claim is HO. A car dealership announces that the mean time of an oil change is less than 15 minutes. So less than, guys, you just put the sign. It has to be here. Don't put it in HO because you read the HO comes first. No, sometimes you have to write HA first. So less than 15 minutes, and that's where the claim is. And now you guys, you can see what the null hypothesis is going to be. If you have any questions, please ask me. 3, Census Bureau data shows that the mean household income in the area served by a shopping mall is $72,500 per year. A market research firm questions 100 shoppers at the mall to find out whether the mean household income for mall shoppers is higher than that of the general population. Who can tell me the null and the alternative? What does higher mean, guys?
Greater than?
Greater than, exactly. That's what we need to find out. If people who live in that area make more than the average salary of $72,500, exactly. And then this one will be less than or equal to. Number 4. Last year, your company's service technician took an average of 1.8 hours to respond to trouble calls from business customers who had purchased service contract. To this year, data show a different average response time. Don't expect the problem to be like worded in very simple words for you. Sometimes this is how it is worded. How can you get the null and the alternative from this? Okay, he's talking about average, guys. So that's a hint for you. Should be mean. Now, who can tell me what are the null and the alternative hypotheses here? To this day, year's data show a different average response time from last year. Suggestions? Okay, let's see what we have here. Yes, you are correct. Equal or not equal. Average of 1.8, not equal. And he's asking, is it different? That means the claim is right here. Okay. It's not, I don't just select anyone to be the claim. It's whatever the question is, that would be the claim. A manufacturer of tires claims that less than 3% of their tires are defective. He's talking about percent, guys. You cannot use the mean, so it's a proportion. So HO, HAP, less than 3%. Here you go. And that's the claim. And that's greater than or equal to 3%. I hope, guys, you're having a good feel of how to state the null and the alternative. Okay, I'll number 6. See, quite a bit of those. A senator running for office again claims that he has a majority of voters. We talked last time about majority. Majority means your percent is over 50%. Proportion is over 50%. So P, over 50% can't be in HO. It has to be in the alternative, because the alternative take the greater sign. That's the claim. And this is less than or equal 50%. When he makes a statement that the senator thinks that he's going to have more than 50% of the votes, that means the previous belief, it was less than or equal to 50%. That's why he's making the statement, because he wants to challenge the previous belief, the status quo, which is the null hypothesis. So always the HA, guys, is made to challenge this one and to prove it is wrong. The standard deviation of waiting time at a restaurant is 12 minutes. So sigma now. Sigma, it's a standard deviation, simple. Is, guys, don't mistake it, it's just equal sign. And then not equal. Now, where's the claim here? It happened to be in HO. Any questions, guys, about stating HO and HA? Okay. There are two types of errors in statistics. No matter which hypothesis represent the claim, always begin the hypothesis test assuming that the null hypothesis is true. So when we test a claim, guys, we have two statements, the first one and the second one. We will assume that the first one is true until proven otherwise, unless proven otherwise. Again, it's just like the defendant case. We assume that the defendant is not guilty unless if we can come up with enough evidence beyond reasonable doubt to convict, the person. And that's exactly how hypothesis test works. At the end of the test, guys, you have to make one of two decisions. You either gonna reject the null hypothesis or you're gonna fail to reject the null hypothesis. So you're gonna learn today, guys, how to use the data, the data from the sample to make a decision, either to reject the null hypothesis or fail to reject the null hypothesis. And this is the whole idea of hypothesis testing, just to show you what to do to make one of two decisions. So this is whether you reject this one or fail to reject the null hypothesis. Let's go here to question number 6, guys. If you end up rejecting this one, HO, that means you're saying HO is bad. Then automatically you can say HA is good, because they're competing hypotheses. If one is false, the other one is true. Now, if you don't reject this one, that means you cannot support that one, because you said that this is probably good. I cannot reject it. That means this one probably bad. That's how hypothesis testing is going to work. So you will see that later in an example. We still have some more definitions to do here. Okay. Because your decision is based on a sample, guys, there is a possibility of making the wrong decision. When you collect data from a sample, if the sample was not an excellent representative of the population, it is very possible that we'll end up making a wrong decision because we don't have the entire population. We're surveying only a sample. So there could be a wrong decision, but we'll try, just to eliminate, just the possibility of making a mistake. So I'm going to define two types of errors here. There's a type 1 error in statistics and a type 2 errors, and let me give you the definition. A type 1 error occurs when you reject HO when it is in fact true. Is that a mistake? Yes, I'm rejecting something that is true. For example, you tell me 2 plus 2 equals 4, and I tell you, no, I don't think it is 4. I'm rejecting something that is true. That is a mistake from my side to say that. That is what a type 1 error. So remember that type 1 error occurs when you reject HO when it is true. Let me tell you what type 2 is. When you fail to reject HO when it is false. You fail to reject something that is false. Let me give you an example, guys. I'll tell you 2 plus 2 equals 5, but because I'm the teacher, you don't want to disappoint me or embarrass me, you tell me you're correct. But 2 plus 2 is not 5, it's 4. So you fail to reject something that is wrong. I made a wrong statement, no students rejected that one. This is a type 2 error. So you need to understand the difference between those two types of errors, okay? So I'm gonna come back to this table, guys, and I need your help with this one. Tell me if we make a correct decision or a wrong decision here. If HO is true, let's assume it is true, and we don't reject it. Did we make a correct decision or a wrong decision? So HO is true, and we don't reject it. What do you guys think? Correct decision or not correct decision? Right here. Any comment? Correct decision, definitely. It is true, and I'm not rejecting that. So I'm telling you, x plus x equals 2x, and you tell me, yeah, we think you're right. So that's a correct decision. That's what we hope for in statistics, that we make the correct decision. But there is a chance, guys, that based on the sample that you end up making wrong decisions without knowing. Now, HO is true, but you reject it. I'm here, guys. We know HO is true, but we end up rejecting it. You guys agree with me that this is not correct decision, but which type of error? Is it type 1 or type 2? Read the definitions. That's type 1. That's a type 1 error. Statisticians try their very best to eliminate this the chance of making a type 1 error. Now let's go to this one. HO is false, but you don't reject it. Is that a right, wrong or decision or correct decision, guys? It is false, we don't reject it. What do you say?
Wrong decision.
Wrong decision. What do we call it? Which type?
Type 2.
Type 2, very good. HO is false, and you say, I don't want it. It is false. You reject it. That's a right decision, guys. Correct decision. Okay. Let's do an example, guys, of what happens in real life when you make those type 1 or type 2 errors. They could have very serious complications if we make those mistakes. So let me give you an example. I'm going to show you this example, guys. So just remember the definitions. The USDA limit for salmonella contamination for chicken is 20%. So they said you can have up to 20%, contamination of salmonella, and you still can eat, the product, no issue, no health issues. A meat inspector reports that the chicken produced by a company exceeds the USDA limit. So an meat inspector went to a company and found out that the level of contamination is more than 20%. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will type 1 or type 2 error occurs? Which one is more serious? Okay, so let's state HO and HA first, and then it's about 1%, guys, of contamination. Okay. The claim is that the meat inspector says it's more than 20%. So P is more than 20%. That's the claim. And here P is less than or equal to 20%. If the meat has 20% contamination, that's good, that's accepted. But if it has less, the better, the lesser, the better, actually, less contamination. So this is HO. And this is HA. What is type 1 error, guys, here? Let me show you. Type 1 error is when you reject HO when it is true. That's type 1 error. Meaning the level of contamination is 20% or less, but the meat inspector end up saying, no, that's not true. I think, just the contamination is more than 20%. He made a mistake. And that's what type 1 error. Okay, so state the type 1 error means the percent of contamination is indeed less than or equal to 20%, but the meat inspector fails to realize that. Tell me what happened in this case. If he goes to a meat market, the level of contamination is 20 or less percent, they're good, but the meat inspector make a report that it is more than 20%. What will happen to the meat on the shelves there? What would he order, just a company to do? If he tells, just the supermarket or the meat marketplace that you have level of contamination of more than 20%, what's the action that the business has to have to take right away? Can someone share an insight with me? What happened to the meat that is on the shelves there? They will have to take it off the shelves. They can't sell it. And that's a loss, for the company because of the mistake, of the meat inspector. Does this happen? It does happen. We received, just lots of times, just that you buy products from places and then you receive an email or a mail telling you, just this product, they found out it was contaminated, but then later to realize, that there wasn't, or suspicion of contamination to realize later that that wasn't true. So the cost of type 1 error, guys, is the business is going to lose money, not rightly, just because the inspector, just wrote a wrong report. So that's type 1 error. It will cost money to the business. Now let's state type 2 error. Type 2 error, guys, when you fail to reject HO when it is false. That means HO is false. If this one is false, that means that one is true. That means the level of contamination is more than 20%, but the meat inspector fails, just to realize that. So level of contamination. Is more than 20%, but the meat inspector did not realize that. And that's serious, guys. And tell me, why do you think this is, why I think it's serious? What does it mean when the meat inspector checks the meat and say it is good to eat, but actually the level of contamination is more than 20%, and he failed, just to acknowledge that? What will happen in this case? What will happen to people when they eat meat that is contaminated?
Get sick.
They get sick, exactly.
Maybe food poisoning.
Yeah, food poisoning, exactly. So which error is more serious? Definitely type 2. Because people will get sick or have because of food poisoning. The contamination, guys. Exactly. So I would live with loss of money to the business rather than a meat inspector doesn't know what he's doing and tell me that your meat is good to eat. And it does happen sometimes. Sometimes it's an honest mistake. Sometimes it's unintentional. People want to make money. They want to sell their products one way or another. But if they get caught, they get in serious trouble. You know that. So, but type 2, guys, in this situation is a more serious one. It's very serious. People will end up at the hospitals as a result of eating, just contaminated food or meat. What statisticians try to do, they try to make type 1 error a law. They try to reduce the chance of type 2 and type 1 at the same time. But the problem is type 1 and type 2 are two competing errors. If you manage to reduce the first one, the other one goes up. And if you manage to reduce the second one, the first one goes up. So you have to find a balance, between the two errors. But at least I explained to you what's the meaning of each one. Okay, so that's type 1 and type 2 errors. Okay, let's give you a definition, more definitions before we get into a real hypothesis test. Level of significance. They call it alpha. So get used to this Greek letter. It's called alpha. It is your maximum allowable probability of making type 1 error. When you do a hypothesis test, because you're getting a sample, guys, you're not surveying the entire population, so there is a chance of making a type 1 error, rejecting HO when it is true. That's a mistake. It could happen, but we try to make this chance, just as low as possible. And alpha is called your maximal allowable probability of making type 1 error. So this is the probability, the chance of making type 1 error. The common values of alpha are 10%, 5%, and 1%. For the sake of FDA, and especially in medical fields, they require alpha to be only at 1%. They want, just the chance of making a type 1 error to be as low as no more than 1%. So you got to have confidence in your claim results, 99% confidence in your claim results, and 1% chance only of making a false decision or wrong decision. Where did I come up with a 99%? Because you subtract 1% from 100%, you get 99%. Okay. Now, for the p-value, guys. This is the big thing here. Okay. As I told you guys, we're gonna make a decision. You're gonna learn hypothesis testing. There are 5 steps. One step, which called step 4, which is the most important step in the hypothesis test, is to make a decision whether you reject HO or fail to reject the null hypothesis. So reject the null hypothesis or fail to reject it. You can't just do both. Either I reject or I don't reject the null hypothesis. What's gonna help us, just make a decision to reject the null hypothesis, fail to reject the null hypothesis, is what we call the p-value. And the p-value, in order for you to understand the meaning of the p-value, I'm gonna have you watch a couple videos right now. So just bear with me to play the videos, and you tell me, guys, that you're getting a sound once I play them. So just give me a second.
Tell me about this p-value thing.
Why do you ask?
We're doing this thing called hypothesis tests. And when my instructor started talking about p-value, my head began to hurt.
Well, it can be a bit confusing. Even professors have been known to explain it incorrectly.
Maybe that's my problem. I wish.
Let's do an experiment.
Ah, if we must.
I'm going to toss this coin.
Okay. I like gambling.
It came up heads. What do you feel about that?
I'm okay with that. After all, there is a 50-50 chance it would come up heads.
Why do you say that?
Well,
Oh,
there are 2 possible outcomes, heads or tails.